Right. Join. All right. So, any questions from previous session we had? Okay. So, if there are no questions, then we can proceed further with Numpy practice questions as well as practice programming questions. Am I audible now? Hello. Is my voice clear?
Yes, sir. Sir,
Hello, Yogendra. I cannot hear you clearly.
sir, I can do.
Okay. Is it only me or everybody else is having trouble? What Yogendra is saying? Understand?
Yes, same with me, sir.
Okay. Okay. Yogendra, maybe you are having a network issue. Can you please type your question in the chat box?
Sir, I am not having any question. I was just confirming.
Okay. Okay. Yeah, we can hear you now. It's clear now.
So can we ask the queries right now, or like you'll take the queries at the end of the session?
So, Tarang, your queries belong to which part? The part that we discussed last time, or it belongs to the part that we are going to discuss today?
So sorry, sir. So I didn't join the last session.
Okay, okay. Go ahead, Tarang. Let me tell me what is that you want to ask?
So I want to ask regarding like just so 1.8 like 1.8 session, and in the slide like 52 slide of the like week one last PPT. So regarding the accuracy,
I see.
so it's mentioned like accuracy is not an ideal metric whenever we have imbalances in the labels.
That is
So
true.
I'm not able so I'm not able to understand this.
Okay,
Can
okay.
you elaborate this?
Sure, Tarang. So, I'll give you just a brief example. Suppose your data is imbalanced. This example I'm repeating from the last session. You have a data set. There are 99 samples which belong to negative category. Let's say we want to detect whether somebody has cancer or not. So 99 samples belong to negative category. They don't have cancer, and there's only one sample with cancer. Okay. So when you train your model, you can train a model which always says no. Okay. So basically, your model, whenever a person comes, whenever a new sample comes in, your model is always going to say no. So what will be the accuracy of your model?
99%.
Absolutely right. But what is the effectiveness of your model? It is never going to catch any positive sample, right?
Right, got your point, sir. Got your
Yeah.
point.
So that's why, and if you measure its FN score, uh, it is going to come out to be 0. So there are 3 more metrics that we look at, just not just accuracy. There is precision, recall, and FN score as well.
Right, got your point.
Okay. So Tarang, there
Thank
will be more information on this when we will be studying classification from week 4 onwards.
Okay, sir. Thank you.
Okay.
Hello, sir.
Yes.
So could you please explain PR curves and all, like all those curves? Like I didn't understand what they meant. Like,
Mehak,
yeah.
can you please speak a little louder?
Yes, sir. Like in the lecture, sir explained about PR curves and all. Like there were 3 curves, ideal curve and all. Like I didn't understand the curve part. Like in this, can you please explain that?
Okay. So Mehak, that is going to take a lot of work. I'm not dodging the question. What I'm saying is, can you start a discourse thread so that we can have a detailed discussion on that? By the way, we are going to have the discussion in week 4 onwards because that part belongs to classification.
Okay, sir. So it will
Okay.
be in depth in that week.
Sorry, Mehak.
So it will be kind of explained in week 4. Like it was just a brief thing. Like it will be explained.
Yes, absolutely. But I would still encourage you to start a discourse post. Okay, we'll have a discussion over there.
Okay, so I will start it then.
Okay.
Yeah.
Thanks, man. All right. I hope that you're able to see my screen. Is it visible?
Yes, it is.
Okay. So, in the last session, we had gone through all the practice assignment questions of week 0, and we wanted to proceed from the programming practice part from week 0 and week 1. So today will be these 2 topics only. Okay. So let's go over here. Okay, due to testing, there are correct answers filled in. That is what you will see, but try to ignore that and attempt the question as if you do not know the answer. So the first question is: accept a positive integer n as argument and print a Numpy array of zeros to the console. Okay. So how would you go about solving this question?
NP dot zeros and then in bracket n will come.
Okay, so your answer is np dot zeros, then
And n also will be read, like read n as well. Like in the first time we will say read n, like input, like n
okay.
and
May
then
can you type in your answer in the chat box?
yes, sir.
Okay, I'm saying okay. So first thing is we are going to take inputs, np dot zeros and okay. Suyash has also entered his answer. Great. Okay. So let me solve it now. So first thing that it says is take a number n is equal to input, and since Python is going to read it as just a string, so I have to convert it into an integer. Okay, that's the first step. Second thing is print a Numpy array of zeros to the console. Okay, as an argument. Okay, the next thing that we'll have to do is I'm going to just call it a variable a is equal to numpy.zeros, and this is going to accept n as argument. Okay, and then print a. Okay, so this is what this question asks. Let's submit it and see. Okay, submission successful. 2 out of 2 private test cases passed. So Mahek and Suyesh, both your answers were actually on the spot. Any questions so far? So by the way, what does this function do? Zeros.
So this will print the zeros, means n times 0, the number of inputs.
Okay, okay. So it is slightly more interesting than that. Let's say, okay, so by the way, if I want to, let's say, import Numpy as NP, and if I want to see the documentation of this function zeros, how can I do that in Google Colab? Anyone? Anybody?
So could you repeat the question, please?
Yes, my question is, I'll type in my question. How to read, see documentation of any function / API.
Sir, we use the question mark
Fantastic.
followed by the function.
Exactly. So question mark np dot what is it? Zeros. Right. And what happens if I okay, let me execute this one first. Yes, it is going to give you the documentation. So there it is. So this is the doc string that is passed along with every API inside Numpy library, or typical with well-written Python libraries, doc string is provided, and typically that contains the documentation. So the job of this is create a matrix, not just array or matrix of zeros only. So instead of passing just one argument, if I pass 2 arguments, not 2 arguments, I should say a tuple with 2 entries, let's say, then it is going to give me an array of zeros, and this is going to be the shape 2 by 3. Okay, if I just pass 3 or 2, okay, that is going to give me 1-dimensional array of 2 zeros. Okay, I hope that it's a bit more clearer now.
So what does a dot signify after 0? I mean, there are times when it doesn't come and there are times when it comes.
This one, okay, 0 dot. This is what you're referring to?
Yeah, yes, sir.
Okay. So this means that this is this is related to the representation of the numbers inside this array. So the numbers of this array are floating point numbers. Okay, so let me show you that. P is equal to this. I'm storing it. print type of t 0. Okay, if I see this, it is going to show me it's a floating. So this is the data type of the numbers which are being stored in this array. So it's a floating point number. Each entry in this array is going to take 64 bits. Okay.
Okay, sir. Yeah.
Okay. There's one more thing that you can do. I think. Let's type int 8. Okay. So just a minute. There it is. So if I give it integer, this time what I'm trying to do, by default numpy.0 creates floating array of floating point zeros. If I want to convert that into integers, I can do that by doing this as type int, and this time you can see that its type is integer. Each entry in this array is an integer, and each of that gets 64 bits. If you print t this time, you will not see the dots. See?
Yeah, fine, sir. Yeah, got it.
Okay. Okay. Now coming, yes.
Like there's no comma here, it's like space. So in integer they don't put commas.
In integers, they don't put commas. Sorry, I didn't get you.
Like we have 0 0, right? So there should be a comma between them. Like in the previous example, between float values, we had comma between two values. But here,
Yes. Yeah, I agree with you. So for integers, it is not printing the commas, is it? Right. Yeah. Okay. So good observation. One more question. Let's say instead of before going back to a set of questions of week 0, what if I put another question mark before numpy.zeros? What's going to happen then? Okay, let's execute it. Okay, so if I try to put double question marks, what is going to happen is it doesn't happen for all the APIs, but if the source code is available, that will be shown over here. Okay, not just its documentation. So keep this point in mind. That might come handy. All right, now going back to our questions. So this question is solved. We can even compress this question in a few ways. So for example, n is being used only once. So what I can do is I can get this thing over here and paste it and remove it all together.
Shape also we have observed the same thing. One comma will be there extra.
I'm sorry, I cannot hear you clearly. Can you type in your question? Okay, and while you're typing in, we can do some questions. Shape also will add extra comma. Sorry, Kaushik, I didn't understand that statement. Shape will add extra comma where? Please, Kaushik, add an example also. What you're referring to? Okay, and while you're doing it, going back to our question. See, A is an array which is being used only once. So if you want to even compress this code even further, not always recommended. Putting so many things to fewer lines of code. Sometimes it can pass. So if I submit it, same results will be there. Okay. Any questions so far?
No, sir.
Okay. All right. Okay. So now going to question number 2. This question says, write a function named mean, that accepts a matrix Numpy array basically as argument and returns the mean of the columns, which should be a vector. Okay. So one hint that I would like to provide you is that all the answers of week zero's practice programming assignments can be written in one line, or maybe when no more than one line of significant effort is needed. So for this question, would you like to type in the line? Okay, Shailesh has written answer numpy.mean x comma x is equal to 0. Anyone else wants to try this? Okay, x dot mean x is equal to 0. Okay, numpy dot mean. Sunita, great attempt. Shailesh and Sunita, I think both of your answers are right. Okay, so either we can call mean method from Numpy library or the mean method from on the array itself. And if you want to add, or sorry, take the mean of every column, we have to provide x is equal to something. And so in this case, we are going to provide 0 because we want to do the operation column wise. Okay. So by the way, since we are looking into access for the first time, what can anybody tell me why is it x is equal to 0 and not x is equal to 1?
So x is equal to 0 means rows and x is equal to 1 means column.
X is equal to 1 is
If we have to represent rows, then we have to choose x is equal to 0. In this case, in this question, they have specified that we have to calculate mean of column. That's why I have used x is equal to 0.
okay. Okay. So there's this special concept of access. So let's say if I have okay, I'll come to that point. So your answer is correct. We are going to use as x is equal to 0 because what you want to do is we want to perform the operations on each and every column, this particular option every column. And what is going to happen is x is 0 means along the rows. Okay, not I should say parallel to row. So row axis is okay. Maybe I should draw a diagram. Give me 1 minute. Okay. I hope you can see this screen. So let's say this is your array. There would be many items. Basically, it is m by n shape. Okay. So the axis concept is slightly unique to Numpy arrays. This is your first axis, and this is your second axis. Okay. So first axis, it is, since we use zero-based indexing, its index is 0, and this one has index 1. So if you want to perform any operation parallel to axis 0, okay, that means you want to perform sum, or you want to perform mean, or you want to perform some other operation, okay, parallel to first axis, you have to provide axis equal to 0. Okay. And similarly, if you want to perform any operation 1 row at a time, okay, then what you will have to do is you have to provide axis equal to 1. Okay, slightly counterintuitive when you see it for the first time, that axis equal to 0 is row wise operations, so you expect that mean would be taken like this, but that is incorrect. Okay, so keep this point in mind, that would come handy. Okay, now coming back to our questions. So any questions so far? Okay, now let's move on to the next question. Okay, this question says X is m by n matrix, W is an n by p matrix, B is a p-dimensional vector. Write a function named compute that accepts X, W and B as arguments and returns the value of the following expression. Okay, so please try to solve this question and write your answers in the chat box. Okay, Aditi has posted her answer. Okay, Shailesh has also posted his answer. Okay, let me take okay, anybody else who wants to share? So please share if you, even if you know already how to solve this problem. It's good that if you type in your answers in the chat box, so that your participation increases. Okay. Mac has a question. What is the difference between star and @? All right. So, okay. I'll while others are typing in their answers, Mac, I will quickly answer your question. Let's go to Colab. Okay. So first of all, A is equal to np dot a range. Let's say 1 to 10 shape 3,3, and there's another np dot a range 11 to 20 dot b shape. So what I've done is I have created yes, Shailesh, I think he has answered. So if I try to print a comma b, you'll see an output like this. Okay, there are these stories. One starts from 1, 2, 3, 4, 5, 6, 7, 8, 9. Another one is 11, 12, 13, 14, 15, 16, 17, 18. Okay, so if I type just a star, this is your answer going to be. Okay, so what it is going to do is it is going to print, multiply the two matrices element wise. Okay, and if you want to compute a dot product or vector product, then you have to use matrices. So this is the difference. Okay, so now coming back to our question, the answer is already been there for pasting. Okay, so I think this is Aditi's answer. Return value. Aditi, I will just make one change that you don't have to add parentheses over here. Okay, and submit it. Yes, submission successful. All the test cases passed. All right. Any questions so far? All right. All right. So let's go to question number 4. Write a function named predict that accepts two vectors w and x as arguments. It should return the value 1 if w transpose x is greater than or equal to 0, and -1 if this quantity is less than 0. Okay, this value is called the label. Don't worry about the label. As of now, it will become clear in week 4. Okay, okay. So this question, takes a bit of a simple task from week 4 and ask you to accomplish that with the Numpy library. Okay. All right. Aditi has posted her answer. Take 2 minutes and write your answers in the chat box. Okay, I'm seeing answers from Chiranjeevi and Shailesh. Okay, another entry from Suyash. Great. Okay. Okay. One more entry from Vishakha. Right. One more from Ish. Right. All right. Right. Okay. Okay. So I have one question to following students. Upesh,
Yes, sir.
Shaka, and Chiranjeevi. Okay. So you have taken transpose of W, right?
Right.
So can you tell me what is the transpose of a vector in Numpy? See, if I use Numpy,
Yeah, row
transpose
vector.
the
Yeah, it will turn into a row vector.
okay. Okay. So let me take another example. Let's say if I have W is equal to Numpy dot random dot random, it's a 4. Okay, and if I print it, this is what I get. Okay, this is a vector of 1, 2, 3, 4. 4 entries. All right, and all of them are actually randomly generated numbers from a normal distribution. Okay, with mean 0 and 1 as standard deviation. All right. Now I take another one. X is equal to same thing. All right. Now what I want to do is I want to take transpose of W. I can print. I can do it two ways. Numpy dot transpose W. What am I going to see? Can anybody tell me?
Will be like 4 sublists.
Pardon me?
I mean, the items in the vector, they like list in itself, one item in each list.
One item in each
list, because rows will convert into columns.
I see. I see. So what you're saying is okay. Okay. So right now, before, so I'm going to create another variable WT is equal to NP dot transpose W. Okay. So just to compare W and WT. Okay.
Yeah, there is a typo transpose.
Okay. Yeah. Thanks. Now, if I execute it, now what I want to do is print shape of W, which should be W dot shape. And same thing I want to do is
WT.
Exactly. So what should I see for W and what should I see for WT?
4114.
4114.
Oh,
Good,
sorry.
good.
Other way around. 1441.
1441. Okay, let's see this. Both of them are 4, nothing.
Okay, this is a single. Okay, it's not a matrix basically.
Yeah. So keep this point in mind that Numpy, when you are actually using Numpy library for representing matrices and vectors, there's a slight difference. Okay, you cannot just blatantly or without care take any vector and convert it into a Numpy array and hope that everything will go fine. Sometimes this breaks when you write big programs, large programs which have possibly hundreds to thousands of lines of code. Then it's better to keep this point in mind. Okay, and so Numpy array by default I have created. So this array is one dimensional, both W and not to mention WT also. So one dimensional array, when you transpose it, there's no other dimension for it. Numpy doesn't have the second dimension, so it will not change the shape at all. However, if I do this, and now I'm introducing another dimension. I am giving it 1, 4. Okay. So now this is going to create an array of 2 dimensions. Even though it is still a row vector, right? But now the Numpy will consider that it is a 2-dimensional array. So if I transpose it, now you will see the difference that you are seeing: 1 by 4 and 4 by 1.
Okay.
Okay. So just to
So, sir, in this case, like if we use transpose, it will not impact the one-dimensional array. So do we need to care?
no. If it is one-dimensional array, transpose is not going to have any effect. So you don't need it. Okay.
A good point. Thank you.
Pardon me?
It was a good point. Thank you.
Yeah. Okay. Yeah. That's my intention was, because Numpy is a big library to become master of. So I'm just adding here and there what I from the mistakes that I had committed, and then what I learned.
Thank you.
Okay. Now let's copy Bhupesh's answer and see if it runs. So I'm going to remove this transpose line. Okay, he has this. So I'm going to do this. Let's remove it. Okay, so basically, when we are writing transpose, it is actually W, or I can do this. Okay, so the product of W and X, whether it is written equal to 0, written 1, that's written -1. That's all this. Yes, submission successful. All private test cases passed. Okay, any questions so far? Okay, then let's move on to the programming questions of week 1. So any questions in general about Numpy library? I hope all of you understand concatenation horizontally and vertically, column stacking, row stacking, and so on.
Hello,
Okay.
sir.
Yes.
Sir, I have doubt in columns.
Okay, tell me.
Sir, can I share my screen?
I'm not sure. You can type in your code though. Yes, Neeraj, I can see your code. So I'm going to, for everyone's visibility, I'm going to copy that code inside the collab. Okay, so what you've done is you have written a function add_1. It takes x, okay, numpy.column stack. Okay, numpy.1. It will create a numpy array of this and address column. Okay, tell me what's your question.
Sir, here after column stack, if I use 2 brackets, then the code works perfectly fine. But if I use only 1 bracket, then the code doesn't work.
So you are saying that this particular this bracket, right?
Yes, sir.
Okay, I understand your point. So by default, column stack does not accept just some, so, okay. So whenever in doubt that why is it not working, see it's a documentation. Okay. So question mark numpy dot column stack. Okay, let's see. See, the first parameter, or actually there is only one parameter. So one parameter that it accepts is tuple, a sequence of 1D or 2D arrays that you want to concatenate. Right. So arrays to stack, all of them must have the same first dimension. Okay, that's all right. All right. So the first, it accepts a tuple of items or the matrices that you want to just suppose together column wise. Okay, so one matrix, this is going to be the first one. Right after that you want to put this matrix, right? So you have to create a tuple of all the matrices that you want to put together or stack column wise. All right, so that's why you have to enter this another set of parentheses.
Okay, sir, got it.
Okay. All right. So you can do one more thing. See, let's see an example. So numpy.once is there. Let's call it. Numpy.arrange. Let's call 3. We call it again numpy.arrange. This time starting from 3 to 6. Let's see what's the answer. Okay, so now you see 0, 1, 2, that's one column, 3, 4, 5, that's another column, and you can provide one more. Any number of matrices that you want to provide. Okay, arrange. I can start with this time 6, and instead of 3 items, I want 6 items. Okay, so this should be 12. Oops, I made some mistake, I think. Yes, the mistake is that the dimension, the size of this is not going to be 3. So I have to reshape it. Reshape it 3 comma minus 1. Now it works. So the second, this, I can write it for more clarity, something like this. Okay, so my first array is 0, 1, 2. My second array is 3, 4, 5. My third array is actually starting from 6, 7, 8, 9, 10, 11. Based on that, it would have been a one-dimensional array, but I had written reshape 3 comma minus 1. Okay, so 3 rows and figure out the number of columns. So there are 2 columns altogether. Now all these 3 arrays will be stacked column wise, and you can provide even more number of arrays as you need or as you wish. Okay, and this will be the answer. Does it make sense?
Yes, sir. Sir, can I use np.once here if I want to add only once in the first column?
Sorry, can you please repeat your question?
Can I use np.once here if I wants to add only once in a column?
Of course, let's do that. Numpy.once 3. Okay, column, and that's it. Let's see. There it is. 1, 1, 1, 0, 3, 6, 7, 8, 9. So on.
Yeah, thank you, sir.
Okay. No issues. And I think Ranjit has asked a question that why are we writing -1? Okay. So whenever we want Numpy to figure out the dimension, we write -1. So either I write 2, okay, 3 by 2 since there are 6 elements, or I can write it should have 3 rows and let Numpy figure out the number of columns. I would get the same answer. Okay, so maybe I should copy this and showing this one. Okay, I could have written this something like this also, -1 and put 2. So now it says 2 columns and figure out the number of rows. Of course, the answer is going to be same, 3 by 2 array. Okay, Ranjit. Good question. Let's move on to question number 2. Write a function named scalar multiply. It accepts two arguments u comma k, which takes a vector u and a scalar k as input and returns k times u as the output. Inputs are a vector u and a scalar k. Output is return a vector which is k times u. Okay, this is a rather very simple question, but still I would like you to write the answer for this quickly and share it on chat box. Okay, I have received an answer from Hardik. Okay, from Hari as well. Okay, Shaka has also submitted her code. Okay, so I think this is a rather very simple code. So I'm just going to copy the code that Hardik submitted and see how it performs. This is Python and this. I think it should be right. Yes, all test cases pass. There's nothing to worry. So basically what we are doing is we are multiplying a Numpy array with a constant. So whenever you multiply a constant with a Numpy array, we can use this star operator asterisk, and then what happens is that scalar quantity is multiplied to every element in the Numpy array. The Numpy array could be one dimensional, two dimensional, or even higher dimensional. Okay, so this is how a vector and a Numpy array, sorry, a vector and a scalar could be multiplied. Let's move on to question number 3. Okay, question number 3 says write a function header. It accepts two arguments u comma v as inputs and returns header product of u and v. This product is obtained via multiplying two matrices element wise. Okay, so keep this point in mind. The vectors or matrices are being multiplied element wise. So two inputs are u and v, and the output is element wise product of u and v if the dimensions of u and v are consistent. Otherwise, return none. Okay, so keep this point in mind also, that you have to check whether the dimensions of u and v are consistent, to be multiplied element wise. Okay. Take 2 minutes and write your answers in the chat box. Okay, Aditi is first one to post her answer. Great, I have received an answer from Ravi as well as Chiranjeevi. Okay, some interesting answers. Another answer from Bhupesh. Good one. Okay, one more answer from Vishakha. Great. All right, I'm seeing a different set of approaches. One is using Vishakha's answer uses exception handling. Okay. Okay. So now let me take answer from Aditi and let's see how it works. Right. So I'm going to write a code over here, paste it. All right. So okay, due to copying pasting, its indentation was messed up. Let's fix it. All right. So this is the answer that Aditi has pasted. Aditi, can you tell me why did you use this thing? You are also checking the number of dimensions of U and V that have to be equal.
Yes, because if the dimensions are different for then the multiplication can't happen.
That is absolutely right. So let's say the dimensions are different. Okay. One is two-dimensional matrix and another is three-dimensional matrix. Okay. Then this is going to be false, right?
Yes.
And what will be the value of this? Whether this will be true or false.
This will also be false.
Absolutely right. Yes. So your answer is perfectly valid. If you run this code, it will always give you the right answer. I just wanted to, add this comment that this condition, do you think this is necessary?
No, actually, if U shape already has the dimension part also.
Yes, absolutely right. So when you take the shape of any Numpy array, it also gives you the dimension is inherent to it. So this is going to return a tuple. Forgive me.
Yes.
This is going to return a tuple. This is also going to return a tuple. So the size of the tuple as well as every element in both the tuples, the corresponding elements have to be equal, and then only this is going to be true. So this condition is not necessary. It is inherent in this first condition. That's the only comment I wanted to add.
Okay.
Okay. And there's one more interesting answer. Yes, I think that answer was from Vishaka. That just put the product computation of product of U and V into try and accept block. If no error, no exception occurs, then just return the product or return the. If any exception occurs, since there's only one reason this exception will occur is if U and V are not compatible with each other. Okay. All right. So let me copy this code and see what should be the output. Choose language by P. So okay. I actually logged out. All right. So week 1. Where were we? Question number 3. Yes. It works perfectly. All the test cases passed. All right. So we are at the end of our session. All as we had planned, that all the practice programming questions from week 0 as well as week 1, we have completed them all. So do you have any questions?
Sir, when we try to attempt these practice questions, there are test inputs at the bottom, but they don't match with like. Can you go to the test inputs for some example?
Yes, Bhupesh, sure. So let's look at here. Okay, so I'm here.
So what this input 1 means?
I see. So this input 1 is I should say ID of the test case.
Okay. Okay.
So the test case is not visible to you.
That is deliberately hidden?
Pardon me?
So it is deliberate?
It is not that we want to hide anything from you. It's yeah, but so far it has been deliberate. Yes. So would you like to see the public test cases? Is that your question?
The data, basically, the trick I try is I print the value so I can see them. So I have a workaround, like if you print a
okay.
Yeah.
Yes, you can just type print U and V, right?
Yeah. So then I can see.
Yes, that should.
Just wanted to understand this one. It's just an ID. Okay.
Right. So yeah, you can see the actual test case vectors that are being passed.
Right.
Okay. Any further questions from anyone? Okay. Any question in general regarding week 1 or regarding Numpy library? So yeah, any questions from week 1 or week 0?
Sir, I have a question.
Yes, go ahead.
Sir, I wanted to ask that from week 2 onwards, why isn't Collab notebook provided?
So week 2 onwards, Colab notebook is not provided for exactly one reason. We want you to write that code on your own and practice on your own. That's all.
Okay.
Like, that's a good thing. Once you start writing, then you understand the details of the code. So
Exactly.
Okay.
So
Okay.
I can understand that when you're not copying and pasting, you're not allowed to, or you're not allowed to, or you want to do it on your own. There is a significant amount of effort that you have to put in. You have to keep in memory. You have to not just memorize, but keep in mind that, okay, this is the API that I want to use, and these are the parameters that should be passed to it to get a meaningful or successful result. And you also build muscle memory. So after some time, using these APIs will become second nature to you. And that's something we want you to achieve. That's something we want you to do, because from week 2 onwards, week 2 is still light, but from there onwards, you will see that Numpy library is used extensively. Anything that we want to do with vectors and matrices, we'll just go to Numpy. Okay, and when it comes to your online proctored exam, the proctored programming exams, you will be using Numpy completely for answering the questions. And if you had done this kind of practice, in assignments, you're not copying pasting, you don't have the Colab, and you're writing the code from scratch, even you have read it 100 times, it builds your practice, it builds into your skill, and you're expected to perform really well in proctored programming exams.
Okay, sir. Thank you, sir.
Any further questions? All right. So before we close the session, just one suggestion to reiterate what I have said earlier, or what we had discussed in the orientation session also, that keep practicing. Programming is not difficult. It only demands practice. So the more practice you put in, the easier it becomes for you. And so please keep practicing and learn Numpy library, the concept of arrays, as well as you can. Okay. Thank you, everyone. Thank you for attending the session, and thank you for allowing me to start the session a bit late. Sorry for that. I'll make sure that doesn't. Thank you, everyone. Have a good night.
thank you.
Thank you, sir.
Thank you,
Good night.
sir.